and try to see if we can solve the 6th grade E5 prime factorization. So again, when we think about prime factorization, it is essentially two words. One is prime, the other is factorization. A factor of a number would be anything that is that can divide, like in this case 10, evenly. So the factors of 10 would be 1, 2, 5, and 10. In terms of finding a prime factor, it is simply saying that the factor itself has to be prime. So for us, it's pretty straightforward because the two prime factors will be unique for 10. And in fact, you'll figure out that the prime factors will always be unique for a specific number. So in this case, we're going to go 2 times 5, that equals 10. And notice that none of the other ones even work because 5 times 10 is 50, 2 times 10 is 20, and then 2 times 2 times 5 is going to be 20. None of these three equal 10. So let's actually try and see if we can do this. So the prime factorization of 12. Now the factors of 12 are 1, 2, 3, 4, 6, and 12. 1 is not considered prime nor composite, so it's neither prime nor composite, so never really consider that. 2 is considered prime, 3 is considered prime, because neither of them are divisible by any other integer numbers other than 1 and themselves. So in the case of 2, it's only divisible by 1 and 2. In the case of 3, it's only divisible by 1 and 3. So we have to break 12 into factors that are prime. And again, they have to multiply together to equal 12. So in the first case, it's 2 times 2 times 2, which is 8, times 3, which is 24. That's too big. It's not going to work. In this case, this is 2 times 2 times 6. That's going to also equal 24, so that's not going to work either. This is an interesting case right here. Right? It says 2 times 6, and 2 times 6 does equal 12. However, when we look at it, the 6 right here is not prime because 6 is divisible by 1, 2, 3, and 6. So basically, we're saying, look, this is a factorization of 12, but it's not the prime factorization of 12. So what we see here is this one right here, 2 times 2 times 3. All right? So as we continue with these, really, you should be able to kind of look at these and say, hey, how do I do all of this? So when you try to factor a prime number, it's just going to be the number itself. So pay attention to that as well. And really, sometimes the problems do repeat, but 9 times 9, right? Or 9 is 3 times 3, because 9 itself is not prime. And now we're going to have to write it out. So prime factorization of 3. The strategy for this is to actually try from the smallest prime number. Now, the smallest prime number is going to be 2. And basically, as soon as we look at it, we can determine whether or not it's divisible by 2 just by determining whether or not it's even. So in the case of 15, it's not. So the next number we try will be 3. So in this case, we say, oh yeah, that's 3, and then we'll multiply by 5, right? Because 3 times 5 equals 15. We can do our division. Remember, this little asterisk is going to be the same as the multiplication sign x, right? And I want you to get used to kind of recognizing both ways so that you don't get confused later on. So 35, I try 2, doesn't work, try 3, doesn't work, so it's going to be 5 times 7. And then when we continue from here, 15, 3 times 5, when we look at prime factorization of 2, and then again, 42 is going to be 2 times 3 times 7, right? 2 times 3 is 6, 6 times 7 is 42. 63, we'll look at this and I say, oh, it's divisible by 3. That gives us 21, and then 21 is divisible by 3, which means that we have to multiply by 7. 3 times 3 times 7. And you may recognize it as 7 times 9, which equals 63. Prime factorization of 5, these are always great because it's just going to be the number itself. 68, so when we look at this, when the numbers get slightly bigger, we have to think, is it prime or is it composite? right? If it's prime, then it's really straightforward. If it's composite, we have to still, again, break it down. So in this case, it's even, so definitely composite. It'll be 2 times 34. 34 is going to be, again, even again, so I can divide 2 and then times 17. Really try to do these problems in your head because it's the mental equivalent of weightlifting, right? And so you got to train your mind and really see how it goes from there. So factorization of 26, 95, 5 times 19, right? 7 will be itself. 33 is going to be 3 times 11. 31. Okay, so this is a really interesting case. I know that this number is prime, but how do we check, right? You could try to divide by every single integer less than 31, every single positive integer less than 31. Alternatively, you can just go and have an algorithm by checking just the prime numbers. So try to divide by 2. It doesn't work. Try to divide by 3. It doesn't work. The next prime is 5. It doesn't work. And really, by this point, you're actually going to be done checking, right? Because the next prime up is going to be 7. And so I'll explain some of the theory again in class, but really do think about how you can actually have an algorithm that works. The one I'm using is just saying, hey, the square root of 31 is going to be less than 6. So, because again, 6 times 6 is 36. So this is going to be a little bit higher level, a little bit more advanced, but essentially all I'm saying is I must check all the prime numbers up until the one that is less than the square root of this number. And that's going to be a very, very effective algorithm. And it's really interesting to see improve, but I do hope that you can at least learn to use it before you learn to prove it. So in this case, it'll just be 31. And now that we're in the challenge zone, 45, again, check, straightforward. Now, this one's kind of interesting, right? The divisibility rule for 2 does exist, right? So we know it's not going to be this. We know that it can't be this either because it has a 6. These two do look more interesting. So if I think about it, what is 186 divided by 2? Well, that gives you 93. Well, 93 isn't divisible by 2, so I automatically know that this is, by process of elimination, going to be the answer. But again, 93 is easy enough to factor, so we try dividing by 3, and then it's going to give us 31 left. So we do check it, and we remember from the last question that 31 is indeed prime. So 154, we can say, oh yes, try dividing by 2 first. And so what will that be? It'll be 77. 77 is divisible by 7, and then leaves 11. 2, 7, 11. When we look further, 34, we say divisible by 2, and then 17 we will eventually recognize as being prime. 10 is 2 times 5. 273. This is a kind of interesting one, and let's think through it, right? So we can look at a couple of these, right? And I'm going to cross this one off right from the start because 3 times 13 just simply isn't big enough. It's 39. This is interesting because 3 times 91 is indeed 273. The problem is 91 is not prime. 91, if we were to check, we had to check, is it divisible by 2? No. Divisible by 3? No. Divisible by 5? No, because it doesn't end in 0 or 5. Is it divisible by 7? Yes, it is. And so it actually turns out that it's 3 times 7 times 13. So there we go. Write the prime factorization of 477. Now, this is a slightly more interesting one. We know that it's not divisible by 2, so then we say, hey, is this number divisible by 3? The divisibility rule for 3 is to see what is the sum of the digits. If the sum of the digits is divisible by 3, then the number itself will be divisible by 3. So when we look at this, we say, oh yes, it's 477. So 4 plus 7 is 11. 11 plus 7 is 18. 18 is a multiple of 3. So 18 is divisible, which means that 477 will be divisible by 3. So that will be 3 times. And we can do a little bit of mental math, and we say, oh yes, definitely 100 will fit in, right? So 1 will fit in here. And then we're left with 177. 177 is awfully close to 180. In fact, it's just a 1 multiple off, right? So in that case, we'd say, oh yes, you know, with 180, if I divide by 3, I would actually get 60. So in this case, I would only be left with 59. So in that case, we contemporarily write this. It'll be, 159. And we think to ourselves, okay, is 159 divisible by 3? Because we need to try it again. And we add 1 plus 5 plus 9, and it turns out to be 15. So that means that 159 is indeed also divisible by 3. So how do I actually break this one down? Well, in this case, we take a look and we just say, hey, 159 divided by 3, we can actually fit that in again, and that's going to be 3 times. Well, in the first case, that'll be 5 and 3, so 53. So that's 159. We take a look at 53 and we say, hey, is this divisible by 3? And it turns out that 5 plus 3 is 8, so it's not. We say, is it divisible by 5? No. Is it divisible by 7? No. And then, is it divisible by, well, we don't really need to check anything else because this is going to be it, right? The square root of 53 is slightly more than than 7 squared, but it's less than 11 squared. So checking up to 7 is fine. When we look at 449, again, we try the same thing. In this case, we say, is it divisible by 2? It's an odd number, so it's not. Is it divisible by 3? In this case, 4 plus 4 is 8, plus 9 is 17. No, it's not. Is it divisible by 5? In this case, we try and look at the end digit. Is it 0 or is it 5? No. So in that case, it's not divisible by 5. Is it divisible by 7? Okay, so this is a slightly more interesting one. And how do we check if this is divisible by 7? Well, in this case, we just divide it. So if I try at the very beginning, I can't fit any in here, right, in the first 4. So what about 44? I can fit in 6, right? So 6, 7, 42. So in that case, that leaves me with 29 left. And I say, is 29 divisible by 7? No, it's not, because 28 is divisible by 7. So 7 is not going to work. I can try 11, and I try dividing again. That doesn't work either. So the next primes that come along are going to be 13, 17, 19, and 23. So in that case, I'll pull a sheet of paper, and then we can actually try 13. So if I do 449 divided by 13, what do I get? I can fit in 3 to try to see, so that would give me 39, and then that's going to be 59. So no, 13 is not divisible. We can look at 17, and so 449, I'd say, okay, I can fit in 2 at the beginning, so that's going to be 34, and then 109. So if I multiply by, let's think, 6 won't work, 7, that's going to be too big. And then what about 23? Well, I think in those cases it's all going to be too big. So in that case, what we'll do is we will try 449 and say that it is prime. So the last one that we have is 138. This is slightly more interesting and slightly easier simply because it's going to be multiple choice like this, so we could always check. But again, if we didn't have those choices, we'd say, okay, 138, definitely not prime because the final digit is even, so we know that's divisible by 2. So if we divide by 2 at least once, then that's going to leave us with what? 69. So 69, we think, okay, 6 plus 9 is 15, which means that 69 is divisible by 3. So if I divide by 3, it'll be left with 23. So 2 times 3 times 23, right? It would have been 2 times this right here, 69, which gives us 138, and this is going to be our solution. All right? So this is how you do prime factorization.